And I'm live. That is cool. Today is 4th of December 2025, Thursday. Yep. And with that, let's just begin solving. Not just solving. First, we will have to see which language we are going to go with through the spinner, the magic spinner. And there is a little bit of time, 15 minutes, till the problem is available. So, yep. And we will do three spins, and whatever the language is on the third spin will be the one with which we solve the question. Okay, first spin, first spin. Python would have been easy. Now second spin, C++ would have been more comfortable. And the third and the final spin, the language with which we are going to go with is Go. Literally shit, almost. This was like almost Ruby, but Go. Okay, we will go with Go. That is cool. It is Go for today. Yo, let's go. Like, not even jokingly. And shit, I started the stream 14 minutes earlier because I thought maybe in the meantime we will do some looking up for the language, like getting used to how what the language is. But I have some idea about how Go works, so let's maybe do something. Yep, let's go. Let's write a simple program in Go, or just uh, remind how Go works. Is there is a not package dot go. There's a Go file which makes a module mod dot go, and yes, a Go module. A single directory is one Go module, and if we want to add more submodules to a singular module, we create more directories and add things in that module. And go.mod is the file that defines the name of the module and other things like dependencies also. And yeah, that is cool. Let's go to day 04 and go mod init right here. Local is a local import file. And now we have a Go module here named AOC and part1.go. Here we will write our Go program where I think we should, I forgot, and we have to say package here. Package main, which means this is an executable, and then func main, where our main function will go. Right? Yeah, go. Did yesterday in D both were completed in 81 lines. Feel like I didn't even do shit. Shit, 81 lines is small, quite literally. Oh, shit, D. I have literally no idea about how D works. Linux environments, and let's not C, but let's D. Yes, very amazing jokes. Module, hello. Who even made D? If you're like me and spend, wait, who is writing me? Why are they talking in first person? D programming language. Or yes, officially from the home page. Ah, D is a general purpose programming language with static typing, system level access, and C-like syntax. With the D programming language, write fast. Yeah, write fast, read fast. The thing, write fast. Also, I looked at some CVEs, some exploits, common vulnerabilities and exploits, and some of most of the CVEs above score 8 to 9 were all somehow related to PHP. Shit, why most of the things are what I've heard is 70% of the errors are or 70% of the vulnerabilities are memory based, and I don't know if PHP is memory safe. It, but C and C++ are not memory safe, and I would suppose most of them are by C and C++, but that does not say anything about their severity. You can go to the Chrome flags and turn on the experimental dark mode. Should see easy. See these. Uh, Chrome has inbuilt dark mode. Okay, that is cool. Support the D language. Okay, we can donate them money, but I don't have money. Learn news, community, documentation, invoke external. Okay, why is your example snippet invoking external programs? Short lines. Object oriented. Shit. I suppose because dot this dot this dot this dot this on this. Okay, D is cool. And yeah, I guess. Compute average length of standard for standard in. Import range, we can import inside a function locally. That is cool. Standard IO. Wait, when did the D language came out? 2001. That is very new. What are the big projects in this language? Remedy games, compiler development, GDC, not GCD, GDC, game development by companies like Remedy Games, early projects like Mayhem, and they remain early, they don't expand or something. Large scale systems like Web Framework, Vibe.D, LDC. The said bootstrapped decompiler. Alan Wakes uses D as a high performance scripting language alongside its C++ engine. Backend written in D for Stack 4, which is a game, a commercial video game considered one of the first to be written in D. Okay, so this is not very widely used, but that is not the point. We would even write some program in like brainfuck or something, which is also not widely used. Let's shit. Yes, that is funny, I guess. And cool. Shit, I was thinking maybe the languages that I'm more familiar with, if they come towards the later part of the challenge, that would be good because problems get increasingly more difficult. But okay, here we go. Just 7 more minutes and Go is set up. How do we read standard input? We don't need to read from a standard input in Go. How do we read from a file in Go? But I don't remember. Go by example. fmt os.read file path content.error. This thing returns two things. Yes. If there is no error, we won't check for the error. We can just ignore the error. Content, convert that thing into a string. Read line by line is something we can do. Os open. Here we did read file, and here we are doing os dot open file error defer. Yes, run this function at the end of this file. That is cool. Scanner buff.io new scanner file, right? Create a new scanner and take the input from this file. And shit, yes, this new scanner function takes in a descriptor, a file descriptor, which could actually be pointing to a file, or it could be pointing to a socket, or it could be pointing to standard input. Anything does not matter. Cool. Scanner.scan line equals scanner dot text line d number line print the line is scanner dot text, and this walrus syntax in Go. Cool. Line number plus plus. Okay, and error is not equal to scanner error if this thing and this thing. Why do we have like two of this here? Whatever. No, we do not have two conditions. This is not a condition. This part is not a condition. This is like initializing the error variable, and then we are checking if it is not equal to null. If it is not equal to null, then there was some error, but otherwise we are cool. I guess probably we might use this. Read line by line, open a file, create a scanner, buff IO, new scanner, scan from this file descriptor, take the scanner variable, and scanner dot scan and scanner dot text. So we scan and we get the text. We scan and we get the text. We scan and then we get the text again. Okay. Or we can just read the whole thing as a string and then handle the thing later. Cool. Okay. Both how like this OS, and that is not how we do this. This is how we do this, and file or data would be equal to os dot read file text dot txt, but I have read file. Okay, read file returns two values. Okay, we just need the data, we don't need the error. Print. Okay, I guess we can do that, and yeah, this semicolon is optional. And exit go part one dot go go. How do I run? Go run the current thing and empty because there is nothing in that file. And hello, put this into text.txt and go run this. We have to convert this into a string. Yeah. Data equals string is not defined. Cannot use string data value of type string as byte value in assignment. But we were doing the same thing here. String content read file string content. So what is the problem here? Cannot use string. Okay, we were unable to rewrite data somehow. Okay, data bytes and data bytes, undefined data. Yes, go run this thing, and we do have hello printed to the screen. That is cool. We will have to see. Yes, it will be more difficult. Yeah, we will have to see about OCaml later. First, like shit. That is cool. Krishna, the only truth. The only truth. Interpretative. Give it at least a week to learn before jumping in it. I guess we will see how it goes. And almost there. Okay. And shit, I don't even remember how to make a array in Go. Part one dot Go. We have this thing. I can this can we split? We can split data on new line. Okay, we cannot use the same variable again. There is no variable shadowing. Shit. Okay. And the question is there. And this, let's go. Question number four, not three. Question number four. Here we go. And shit. We would need some kind of map. We won't be going row by row. Okay. You ride the escalator down to the printing department. They are clearly getting ready for Christmas. They have lots of large rolls of papers everywhere, and there is even a massive printer in the corner to handle the really big print jobs. Decorating here will be easy. They can make their own decorations. What you really need is a way to get further into the North Pole base while the elevators are offline. Actually, maybe we can help with that one. With that, one of the elves replies when you ask for help. We are pretty sure there is a cafeteria on the other side of the back wall. If we could break through the wall, you would be able to keep moving. It is too bad all of our forklifts are so busy using those big rolls of paper around moving. Yeah. If you can optimize the work the forklifts are doing, maybe they would have time to spare to break through the wall. The rolls of paper, these things, are arranged on a large grid. The elves even have a helpful diagram or puzzle input indicating where everything is located, for example, like this. The forklifts can only access a roll of paper if there are fewer than four rolls of paper in the eight adjacent positions. Eight adjacent positions. 3 plus 3, 6. Okay. For this one, there are 8, 3, 3, 8 adjacent positions, like Conway's Game of Life. In the 8 adjacent positions, if you can figure out if there are fewer than 4 rows in the 8 adjacent positions. Okay. If you can figure out which rows of the paper forklifts can access, they will spend less time looking and more time breaking down the wall to the cafeteria. In this example, there are 13 rolls of paper that can be accessed. Shit. Okay, first part is easy, but I'm very scared of what the second part would be. Consider your complete diagram of the paper roll locations. How many rolls of paper can be accessed by a forklift? Okay, yes, first half is easy, but I'm very scared of the second part. Okay, we have this thing, and we can even trim. Can we? Is there a trim string dot trim? What does it take? It takes in a string and dot trim. Strings dot split, but before yes. Uh, Not enough arguments in to call the trim. Trim returns a slice of the string S with all leading and trailing unicodes in the okay and cut set. What is cut set? Cut set is a string. Cut set. Uh, cut set removed. Okay. Remove leading. New lines and mm, new lines and spaces. Declared and not used. Fmt dot print and data. Go run this current thing and we just have hello for now, which is true, and we also got rid of the new line, so that is also something. Text dot path puzzle input. We cannot surely do this by hand. Yes, maybe we can, but we are lazy. Part1 dot go and let's go. Okay, we have split the whole thing by line. That is cool. Now we need to make a array, a two-dimensional grid out of this thing. Yep. Let's see how do we say we want a two-dimensional grid. A 2D array in Go. How to make a 2D array in Go? Yep. Shared, yes. Okay. We use the where keyword. I forgot completely how to write in Go. But anyways, where keyword a, here the numbers and here numbers and what those are going to store, and then the object which we are assigning this variable to this variable. Okay. Okay. uh let's say var grid, where the first size would be data dot size length of data, and length of data would mean the number of rows, and here data 0 dot length if it is a function. That thing is a string, and this is going to store bool. Yeah, this is going to store bool. And okay, we cannot dynamically give stuff to things. We will have to use the make function. Make bool. And wait, how do we? Yes, we do. I guess we can use another main function here. We won't be using another main function. We will say length of data. Grid is not used, it does not matter for where I equals 0. Mm, okay. For where I equals 0, I is smaller than length of data I plus plus. Expected this. How to run a for loop in Go. Yeah. Basic syntax, yes. Okay. Or like this. That is also something. But I guess this is not, this does not go by reference, in which case we can use I. Yeah, we can use I, and I guess we should use I for I equals I comma whatever equals range of grid unidentified. Uh, why is it unidentified? Makes sense. And we will say that grid I will be equal to, yes, grid I will be equal to data I dot split and nothing. Or let's say, first of all, okay, grid I equals make boolean, don't say zero, say data something length of this thing. And then we will go through this whole loop for for char in data I for C in data I if C equals this thing. Then let's say, should we also need the index? J, let's say J. And then we'll say grid I J equals true, else grid I J equals false. Oh, and also else comes on the same line, or this could all be in a single line. This thing equals C equals, okay, simplify range expression. First thing is the index, hopefully. And let's print the grid and see how it goes. Go run dot and true false, true false, true false, true false. That is cool. And go part 2. Let's change data with expected expression found new, expected type found new line. Makes sense. String, and this is the data. Okay, cool. Let's see this, and now we'll use vim macro. Shit. Start recording in register A. Go to the start of the line, this thing. Go to the end of the line, this thing. Do this down and quit the macro. Do this like 8 more times. Cool, and one more time. Cool, but there is a error somewhere. Shit. Okay, we messed up the macro. We messed up the macro. Here we are, and we'll re-record the macro. Control A, go to the start, this thing, go to the end, this thing, comma, exit, go to the next line, and quit the macro. Cool. Okay, and we will do this like 9 more times. 9. Okay, it checks out. Go First clear. Go run current file and false, true, false. Is it correct? False, false, true, true, false, true, true, false, false, true, true, false, true, true. Should be true, true again and then false. Yes, cool. Okay. Part1 dot go, and now we will just iterate through the whole grid and yeah, we will find the answer. Response initially equals 0 and at the end print the response for G in or for row, yeah, for row in range grid. We need the index. We need the index, not this thing. I, comma, we don't need the row, or we will also have the row. Row equals this. We don't need the row. We don't need the row. Range grid, and for J range grid I. Yes, and here there are let's have another variable which has all of the directions in which we could be going. Hello, how is everything going? Cool, I hope. Directions, and that would be of, yes, int, two-dimensional array of int. Yes, two-dimensional array of int, and I guess this is how we specify our two-dimensional array. -1, -1. Declarations found direct. There are no global variables. Declared and not used. Declared. Okay. There are no global variables somehow in Go, or there is some other way to manage global variables in Go. -1, comma 0, -1, comma 1, and 0, comma -1, 0, comma 0, comma 0 is not a move that we will be making. That does not take us anywhere. 1, comma 0, 1, comma -1, 1, comma 1. Okay. Okay. Now we have the directions also. For I, no, I want to go through the directions for Z, or directions and range directions. Declared and not used, that is completely fine. I think this is how we can do this. Dx, change in x, dy equals, expecting that. Why? Expected one argument. Or okay, we'll just use indexes. New x equals to direction 0 plus the current x, which is I. Before moving into the directions, we first have to check if the current thing is a paper roll or not. If grid I j, if grid I j, so the current thing is paper roll. Declared and not, that is fine. And that is lot of indentation, 4 levels of indentation. Yep. And okay, now New x would be equal to, let's use new I instead of new x. There 0 plus I cannot, huh? There is an index. Directions, huh? How is, shit, okay. There is actually an index. Let's say di. I think we can break this apart. There is the index for the current direction that we are in. Change in I on change in j would be equal to directions there. If that makes sense, that does not make sense. Unexpected comma, or can we do something like this? No, we cannot do something like this. Anyways, there is the index and directions 0, and new j would be equal to directions their direction, or we can make, we don't actually need the index, that is stupid. One plus j, we have the new I and j, right? We have the new I and j, and let's at this point, after getting the data, we do know the sizes. Yeah, so let's say rows would be equal to length of data, that is how many rows there are. Calls will be equal to length of data 0, and here instead of doing length of data, we can say number of rows and length of data 0. Instead of this, we can say the number of columns. Okay, now if new I is smaller than rows and new I greater than equal to 0, and new j smaller than false and new j greater than equal to 0, in that case, and yes, also let's say uh, count equals 0, counts equals 0, and if grid new I, yeah, and yes, these are independent. If one role is reachable, that has no effect on the other roles being reachable or not. New j, if, yeah, if this thing is true, then counts plus plus, and at the end, if counts greater than equal to 4, right? No, less than equal to, fewer than 4 rows of paper. If counts smaller than 4, then rest plus plus. Should I guess we are done? Go run dot 13 turns out to be the answer there, which is the actual correct answer for the test case at least. Part1.go, print this with a new line. Go run this. Okay, cool. Let's run this for the actual test case. Go run current 1540. That might be correct or might not be. 1540. Okay. 1540, 1540 for the test case, whatever it was, and That is the right answer. Shit. Okay, that is the right answer. Cool. But yeah, I'm afraid of the second part. The implementation for the first part is very stupid and simple, but I'm actually afraid, shaking in my boots for the second part. Now the elves just need help accessing as much of the paper as they can. Okay, once a roll of paper can be okay, it can be removed. Once a roll of paper is removed, the four clerks might be able to access more rolls of paper, which they might also be able to remove. How many total rolls of paper could the elves remove if they kept repeating this process? Wouldn't they be able to remove all of them? If they can remove at least one, I guess they might be able to remove all of them. Starting with the same example as above, here is an example. Here's one way you can remove as many rolls of paper as possible using highlighted this to indicate that a roll of paper is about to be removed, and using X to indicate that a roll of paper was just removed. Okay, here we can remove all of these papers. We remove them. Now 13s were removed, and then 12 more rolls were removed from this state. From this, 7 more rolls were removed. From this, 5 more rolls were 2 were removed from this one, this and this, and after this 2 more were removed, 1 more was removed, this one, and from here this one was also removed, then this one was removed, and from this one, little shit, we cannot remove any rule. That is crazy. We can just keep passing. Yeah, we can just keep passing our input to the same function again and again. Yes, because here in the input we don't have like 1,000 by 1,000 lines. Yeah, we can take care of n cubed time complexity. Part1.go, select everything. Part2.go, paste. We have the main package twice, that is sad. Main, let's say main one. Yep, this is the main package now, and here we will outsource. Yep, we will outsource this part, and we will make a new function solve. This will take in a grid, and the type comes later in Go. That is how things are in Go. And this also uses, I guess, rain columns and rows. Yes, columns and rows, we will initialize them at the point. And this will return an integer. Return res grid ij, what is non-boolean. This is of type boost, and directions are needed. Directions are not needed outside. Yeah, so we can declare them here in the function itself, and rows and columns we can declare right here. Rows would be equal to length of the grid, and columns would be equal to length of anything in the grid, and yes, remove the semicolons. There is still one error, which is this. Yeah, let's equal yeah, let's equals 0, and for while loop current equals solve path in the grid. If current greater than 0, then res plus equals current else break. And shit, we want to pass this grid as a reference, not as a copy. That would be very sad. How to pass by? I think it is passed by reference by default when we are passing a grid. Pass a slice by reference in Go. I think it is passed by reference, like by reference by default. Is this thing? Modify the elements directly. My slice, original slice is right here, which must have some capacity. It doesn't matter. Yeah, okay. Output original slice is this. Modify, pass the slice to the function. Modify the slice. Okay, so it is consideration. That is cool. Yes. And so the slice itself is passed, not a reference to the slice. Increase the counts. And if we see that the current thing can be removed, we will say grid I j equals false. Shit, we cannot just say that this thing is false just now. Yes, we cannot say that this thing is false just now because we are yet to remove things, and this might lead us to remove things which we might be removing later anyways. I think this will not cause any problem. Like here, if you are doing grid ij equals false, just as we do realize that we can remove this particular current grid, that does not actually matter, right? We can either make this grid ij equal to false, which means that this current grid has been removed from its position. We can make it false right now, or we can do this in steps like they do here. In one step, they are removing 13 grids, or we can just remove this thing and move forward. I think they are both equivalent. Let's see. And yep, we can use grid, and here remove this. Cool. Data equals one-dimensional string, one-dimensional array of strings. Copy, paste, and Vim macro, we can use the same one that we used the last time. Let's go run this current thing, and answer turns out to be 43, which is the actual answer for the test case 43. There we go. Let's do this for the actual test case instead of for this. And there they said there was some error, which it clearly is right here. Okay, 8,972, which is higher than the last answer, which was 1,540. 1,540. Now 8,900, 8,972. 72 is 8 into 9. That is also funny. 8,972. That is actually the right answer. Okay, shit, that is cool. That is the right answer. Okay, I'm reading this right. That is the right answer. You are one gold star closer to decorating the North Pole. You have completed day 4. Let's see the leaderboard. Personal times. There is no like global leaderboard. This is cool. We did the first part in 23 minutes from the start and 32 minutes. So like 9 minutes for the part 2 and 23 minutes for part 1, which is higher than we should have taken because this was not very difficult. And 49 minutes. Shit, yes. Today was easy. Today was easy. Yep, today was easy. Also because we had like Go here. We landed on Go somehow. Like twice. What are the odds? 777. Yeah, luck is not too much, but yep, that would be it for today. We did just in 15 minutes. Yep, yeah, that is it. There is nothing much. And also, if you were to go in your advent of code and if you were to also submit 1540 for your first solution, uh, inputs are different on the basis of the user. So your answer is not 1540, it must be something else. Yeah, inputs are different for different users. Get submit M, did day 4 and go. Git push release in 2025 and should also be now on GitHub. And GitHub has still not updated this thing. It is still says JavaScript, just one language. Yep, cool. Did we will not say we did day one in JavaScript. That is something we want to hide. And okay, day one, day two in PHP, day three in Dart, day four in Go, and day five would be crazy. I will remove from this spinner. I will remove Go and crazy languages will remain. Haskell will be there, Zig will be there, OCaml will be there. These are crazy languages. Ruby must be crazy. I don't know. DHH, Zig, C++ is cool. And I would be very happy if C++, I would be very happy if OCaml is not the language that I get on day 12. That would be very sad to get OCaml on day 12. Lua is cool, Rust is cool, C++ is cool, Go is cool, Python is cool. Okay, and that would be it for today. Why O? Just there. I use oh shit. Bro is a working professional, contributing member of the society. Oh, Camel is cool. And this guy said, oh, Camel is like quite different from how we think. I guess I can start looking up oh, Camel just beforehand. In module warning equals struct. And yes, by the way, I will like most probably I will forget everything after using these languages. I cannot become master in just 1 hour of doing a language. Module warning, something in OCaml. Learn X environment. This is how OCaml looks like. There are a lot of comments. Shit, okay, that is strange. Two semicolons is strange. Let type inference. Okay, there is the concept of immutability by default in OCaml, just like in Rust. Okay, let okay, okay, that is a very strange statement since OCaml compile. Okay, I will not read the comment. Let's decipher this on its own. We are creating a new variable called int and we are giving it the type int and it is inferring the value of x and x plus 1. Okay, let's read the comment. Since OCaml compiler infers types automatically, you normally don't need to specify argument types. Wait, this is a function. Shit. Is this a function? This is a function, I think. L Shit. This actually is a function. No. Recursive. We have to specify recursive with rec keyword. Okay, this is how we specify a function. Factorial is the name of the function. Then what is end? N is the argument of the function, and here we are not specifying the type of the argument. W- Here we are specifying the type of the argument and also the return type, and the value of the function is this thing. There are no brackets nowhere. Just calling the function. While calling the function, we are giving brackets with a space in the middle. Okay, is it necessary or a aesthetic piece of art to give a space before after the function name? Hello, empty function. Share. Here we are using these to say that this thing is a function which is equal to this thing. Like run this function whenever we call this function, and this is not and yes, these parentheses are here to say that print hello is a function whose value is this, and not print hello is not the equal to the return value of this thing, which is a string, I suppose, with end line, print end line. Okay, yes, OCaml is strange. OCaml is strange. Sort of similar to Haskell. Both of them are functional programming language. FP, file pointer. Shit, OCaml is strange. Yeah. And yes, like this is a joke right now, going through advent of code and just solving one question in a language. This is a joke. This is not like for learning a new language. And I would hope at some point I would actually seriously learn these languages, because this looks, not because this might help me in some way or another, but because this is, well, this will help me in some way, but because this is just a very different way of looking at things, and that is always cool. Like, look at this. Let recursive function is even is the name of the function, and here it is equal to a function which is doing something with straight lines. And take and wait, we are calling this function on place, or like are we defining two functions, is even and is odd, using the same these two, are we like using these two same characters for this function and this function, and we are saying let a recursive function this equal to this thing, and a recursive function this equal to this thing, or whatever. Cool. Came out. It was in 1996. That is older than D. Anyways, function. They are guards. Same thing in Haskell. Shared Haskell and OCaml. This will be cool. This will be cool and fun. And that would be it for today. 58 minutes, like perfect time to end the stream. And yep, thank you for being here. Bye.